Here's an example from your homework, exactly from your homework. It is page 383, and I'm going to be looking at numbers 49, and the corresponding number that goes with 49 is number 53. So I'm going to be doing both of these problems at the same time. So first of all, we need to talk about what the problem is asking us. The problem is saying that the U.S. Department of Agriculture reports that the mean American consumption of carbonated beverages has increased. Beverages per year is greater than 52 gallons. A random sample of 30 Americans yielded the sample mean of 69 gallons. Assume that the population standard deviation is 20 gallons and let the confidence level be 95%. So let's translate that. So the first thing is that they're making a claim that the mu is above 52. All right. Then they're saying that the random sample, or the N, was 30. So we have a big enough, we have our parameters, our criteria is met. And we have a sample mean of 69 gallons. And we have a standard deviation of 20 gallons. And our confidence level is 95%. So our alpha is 0.05. So that means our Z, alpha over 2, corresponds with, and I didn't write it down. I'm a bad teacher. I should have had it memorized. For 0.05, our Z-score is 1.96. Okay, so the first thing that this problem is asking us to do is to find the point estimate of the population mean. Remember, it's an estimate, so it's our sample, so the point estimate. So for A, is saying that our X bar is 69. B is asking us to calculate the standard deviation over the square root of N, so that way there we won't have to worry about it when we calculate it. So that's 20 divided by the square root of 30. And plugging that into the calculator, 30 square root. So 20 divided by, I'm going to do parentheses, 30 square root. So that gives us, we need a parenthesis and press equals. That gives us 3.65. 3.65. So for C is asking us to find Z alpha over 2, which we did, which is 1.96. And D is asking us to construct a confidence interval. So that's X bar plus or minus Z alpha over 2 times the standard deviation over the square root of N. So now we just plug in numbers. I'm going to pause and plug in those numbers. So our X bar is 69, our Z is 1.96, and this value is 3.65. So now I'm going to plug into my calculator 69 plus 1.96 times 3.65. And I'm going to plug in 69 minus 1.96 times 3.65. And I'm going to pause again and do that arithmetic. So doing out that math yields that the mu gallons of carbonated beverages drank is between 61.846 and 76.0952. We're saying that the true population mu lies between these two numbers. Again, with 95% confidence. The error there is 5%, which is the other other part of the confidence, because percent minus 100, all that. So 53 is asking us to compute the margin of error. So 53A is asking us to compute the margin of error, which is E times the alpha over 2 times the standard deviation over the population, We already know that. That's 1.96 times the 3.65, which comes out to 7.154. Now it's saying for B, how large of a sample size is needed to estimate mu to within 25 gallons with 95% confidence. So here we go with B, and we want our E to equal 25. So we've got 25 equals 1.96, because that's the Z over 2, times the standard deviation of 20, divided by the square root of n. So this needs some fancy algebra. If you need the formula for that, it is located on page 381 on the bottom, and it's saying n equals, because I'm going to solve this for n, but the book has already done it for you, z alpha over 2 times the standard deviation over the error squared. So when I solve for n, I'm going to do some fancy math. That's going to be square root of n is equal to 1.96 times 20 over 25. And then I'm going to square this to get rid of the square root. So that's 1.96 20 over 25. And the whole quantity is going to be squared. So I'm going to pause and I'm going to plug that into the calculator. Actually, I'm going to show you how to plug it into the calculator, so that way there won't be any errors. So 1.96, 96 times 20 equals that divided by 25. And then I'm going to square it. So my n is equal to 2.458. Now, in the back of the book, it says your n equals 3. So the book rounded up. So you need a sample size of 3, because you can't sample 2.45 people. I don't even think we're sampling people. Hold on. Yes, we are sampling people, and you can't sample 2.458 people, so you just sample 3 instead. All right, so C asks us to how large of a sample size is needed to estimate mu to within 5 gallons with 95% confidence. So our error here, we want 5, 1.96 times 20 over the square root of n. So that's n equals 1.96 times 20 over 5 squared. I'm going to do some reducing so I can put less in my calculator. So that becomes 1.96 times 4, because this goes away and that becomes 4. And then that is all squared. So plugging that into my calculator, 1.96 times 4 equals squared. So you need an n of 47.47 or 62, because again, you can't sample 0.47 people. So this should illustrate a good point that the more you sample, the closer you're going to get a smaller and smaller margin of error. So that's all of those problems. Every single one of those problems on 383, 59, all the way to 56 are done exactly like this one. So hopefully that should be enough to walk you through it. And I'm going to get on to hypothesis testing. And by getting on to hypothesis testing, I mean show you examples for p-hat and point estimate. So I'm going to be looking at page 409, number 49, which is also in your homework. So we're going to talk about married millennials. Millennials refers to the generation of young people aged 18 through 29 in 2010. I'm a millennial because in 2010 I was 27. because they are the first generation to come of age in the new millennium. A 2010 Pew Research Center study found that 183 of a sample of 830 American millennials were married using 99% confidence level. So our P hat is the 183 out of the 830. Okay, our N is 830. And we want a 99% confidence level, so our alpha is 0.01. And that Z alpha over 2, same thing. I believe it's 2.576. Let me take a peek. 2.76. Did I do it? Yes, I did. 2.576. All right, so now we need to find our confidence levels. So we go plus or minus Z alpha over 2 times P hat square root of P hat times 1 minus P hat over N. So we know our P hat is 183 divided by 180, which equals, and that is not 180, it's 830. I can't read. So that's 0.22. 0.22. So 0.22 plus or minus 2.576 times the square root of 0.22 times 0.78 divided by 830. I'm going to pause this and calculate that out. So I've done the arithmetic, and our confidence interval for the married millennials is with 99% confidence. The population proportion P is between 0.18 and 0.257. Okay? So now I'm going to talk about number 53, which we need to calculate the margin of error. So A, error equals Z alpha over 2 times the square root of P hat times 1 minus P hat over N. What is going on with my pen? So we know that our Z is 2.576, and we know all of this equals 0.0144. So calculator time, 2.576 times 0.0144. And that gives us a margin of error of 0.037%, or 3.7%. And B is asking us to determine whether the conditions are met for constructing a confidence interval for P. I'm looking at the wrong question. Explain what this value for the margin of error means. And, well, that just means we're off of P by 3.7%. And that's it for the 409 section. All the problems like that will be 409. Make sure you follow the criterias. And now, for real, hypothesis testing.